Welcome to Array Cafe, brought to you by IEEE Sensors Council. Join us for an exciting journey into the world of sensors technologies and how it is becoming better and better day by day. Our podcast takes you through the stories of scientists, engineers, practitioners, and developers who are leading the way in improving sensors in order to responding to the societal challenges. Come along as we explore how these devices are making use of these smart sensors and how they change the way we use technology every day. From getting inspired to understanding to testing and using them, we'll show you all the steps. This is RA Cafe, brought to you by IEEE Sensors Council.
Good afternoon, good morning, and good evening, depending on which part of the globe you are. And today we are here to have a podcast as part of the IEEE Sensors Council and IEEE MEMS training initiative that's been going on. To start with, we have Professor Senturia, who is an eminent and pioneer in MEMS research. He's Professor Emeritus from MIT. Then we have Professor Ananthasuresh, who is the Dean of Mechanical Sciences from Indian Institute of Science, Bangalore, and he's a MEMS expert. And we'll come to that and on his contribution to this activity. And we have Dr. Jeronimo, who is from Texas Instruments in the Bay Area Kilby Labs, and he will give the industry perspective of the MEMS technology. So welcome all three of you, and thank you for accepting this invitation. I would actually begin from where MEMS began with Professor Centuria. And the question I have for you is, how did you get associated with MEMS research so many decades ago? And you must have started way back in 1970s, even before Geronimo and I were born. So how did it all begin?
Well, it began in a very strange way. I was a physicist, and I was working in compound semiconductor physics in the electrical engineering department at MIT. And a colleague of mine from mechanical engineering had a consulting job with a firm that was looking at NASA technology to see what NASA technology might be useful in the civilian sector. And I joined him as a consultant on that program and came across a case of some interesting conducting polymers that appeared to be useful for making sensors for gases, different kinds of gases. I got interested in that because I was interested in doing something practical. So I started working on that. I actually got a small NASA contract to work with a colleague from McDonnell Douglas to create some sensors, and I made some sensors. And then one of my students came to me and said, I think I know how I can put this on silicon. And we had a small fabrication lab at MIT, and we could make transistors, but my group was the first one to make MOS transistors in that teaching facility. And we came up with something called the charge flow transistor. This was in 1976, which was on which we put these conducting polymers and could make integrated sensors. That was my first integrated sensor work. Along the way, I got a sponsorship from the Office of Naval Research, and the program manager made the wonderful suggestion to try this device in sensing properties of polymers that were undergoing resin cure, like epoxy resins. And we started doing that and got some fantastic results. And then we discovered that the real problem was how to package these devices so that they could survive in resin cure environments. And my first paper on packaging of integrated sensors was at the 1981 Materials Research Society meeting in Boston. And that was a seminal meeting in many ways. It brought together researchers from Japan, Europe, and the United States, talking about what we needed to do to move this field of integrated sensors along. And out of it came the International Conference, Transducers, which meets in the odd years, rotates between Europe and Japan and North America. And also, at that time, individual regions were encouraged to create regional conferences. And we created the Hilton Head workshop that is every 2 years, bringing together a community of people. And it was in the community of people that we created all kinds of great ideas. We had Kurt Peterson, who was working in micro machining of all kinds of interesting structures. We had people from Europe, Middlehook, and others from Europe, Esashi from Japan. We had just these wonderfully creative people, and ideas were flowing back and forth. And in the midst of that, I came up with an idea of how to use integrated structures to measure mechanical properties of materials. And at the same time, I was working with a colleague in microelectronics at MIT who was involved in simulation of semiconductor processes. The program that was called Supreme, it was one of the earliest programs for simulating microelectronic processing. And I got the idea that MEMS, it wasn't called MEMS then, but that MEMS needed a design system. And so in 1987, I was invited to give a talk in the Transducers 87 in Japan, in which I talked about an architecture for a design system, CAD system, that would combine mechanical, electronic, and processing all in one framework. And that was one of the big thrusts of my research. Another thrust, though, was to work on wild and wacky things like little micromotors and structures that could be used to measure the adhesion of polymers to silicon. They were very important in the electronics industry. And so little by little, I got involved in more and more things. And what I discovered was that the wonderful thing about MEMS is that everything you know in your life is relevant. Physics, fluid dynamics, electronics, heat transfer, chemistry, everything you can think of is relevant. And as long as you have a good conceptual understanding of how to think about a system, which includes a device, a package, and everything required to make that device work, and you do it all together, you will have a success. Well, after working on the design systems, I then got involved in a program through the Sandia Labs, where I was a consultant, to create some interesting optical MEMS devices, light valves, things that could be used for controlling light in various wavelengths. And this led to my second company, Polychromics, where we created a small infrared spectrometer, very small, very low power. In fact, it was small enough and low power enough to be used to go to the moon and find water on the moon with the NASA L-Cross mission. So the way to answer your question really is that you got to follow your nose from one interesting topic to the next and look broadly at all applicable physical and chemical and related issues that might affect a practical device. And once you learn how to make something practical, it's habit forming, and you want to do more. So that's a summary. It went from adhesion measurements to micromotors to optical MEMS to design systems, but each case finding a problem that needed solving and bringing the resources to bear to make it happen. So I hope that's a good answer for you. I think it should help others understand that this is a diverse and exciting arena, and there's plenty of room for creativity.
Of course, this is a wonderful and inspiring story that you said. And many, and including me, are inspired now about the whole journey that you have taken from sensors to integration of sensors to packaging and even system development through software. The one question I have is, in the whole journey, what is the most challenging part that you've had from sensor development to system development?
The most challenging is to make something that actually works. It's very easy to come up with a concept and to play around in the laboratory and build something that does something interesting. The real challenge is to satisfy the real world requirements that something function properly in appropriate environments and with appropriate challenges, that's hard. And it's not something that's typically done well at universities. I didn't really appreciate how hard it is to do something right until I tried in a company to make a product that could be reliably distributed to other people and actually do something useful. This is something universities don't do very well, but it was a challenge for me to figure out how do you do something that really works.
Amazing. That's very inspiring. Thank you. Thank you, Professor Senturia. Now I go to Professor Ananthasuresh, and I have known him for last 15 years. He's been one of my mentors. If I'm in MEMS, it's thanks to him and all his mentorship. I know that it's been 15 years. 2010 was when this whole idea of MEMS community chip came into your mind, and it was done through the Institute of Smart Structures and Systems, which we call as IEEE in short. How did this whole inspiration come to you about having a MEMS community chip, which is what we are trying to do now at global level through the Sensors Council? How did that come about?
Yeah, yes, Dr. Veda, I'm glad to be here. And you're right, it has been actually more than 14 years since we started in India. But actually, multi-user chips are not uncommon. I had seen them in the US when I was a graduate student and also a faculty member there later. And in fact, used it in the late 1990s. So I would call it not inspiration, but actually motivation to do it. So I did my PhD at University of Michigan, Ann Arbor. And then I did my postdoc at MIT, actually with Professor Senturia, who is here with us now. And both of these, even at that time, that is, I'm talking about early 90s, both of them had excellent microfabrication facilities. They were state of the art at the time. A lot of things could be done. But it was expensive for an advisor to actually let a graduate student learn it and also do it, because they have to have a grant to use the microfab. So actually my first MEMS device was actually made by a fellow graduate student, because I was in mechanical engineering and it was not my primary activity to do microfabrication. So I tagged along with another graduate student and he made it for me. We tested it together, of course. So, I designed it and someone else made it. That's how it started. So that's where the idea of designing and someone else making it started. And when I started my own independent faculty career at University of Pennsylvania, and just like Professor Senturia recalled at MIT, a small fab that was there, UPenn, University of Pennsylvania, also had a very small fab. And in fact, nobody had made any MEMS device there at that time. This is 1996. So I, of course, now UPenn has an excellent facility, not there. So I had to put in a lot of effort to get that going, to actually make a micro-machine electrothermal compliant mechanism there at Penn. But then I also had known about this MEMS foundry, although some people don't like that phrase. At Research Triangle Park in North Carolina, there was this MEMS cap program, what came out to be as MEMS cap later. So that was there. So I used it because it was a lot of effort for me to design and also make it and test it. So I had used it. So that kind of was the motivation when I moved back to India. I saw that there were a lot of modeling, a lot of simulation. This I'm talking about 2004. A lot of people are interested in MEMS, but they were actually satisfied when they use a micro systems CAD software and do the simulations. I thought it would be nice for them to get experience to actually make the devices and test them and see that their designs work. Because in MEMS, right from the beginning, that is the test. You have to actually make the device and see them working, and it had to have an application too. So that was actually the motivation for starting in India, well, in a way inspired by what I had seen in the US.
That's great because it has helped so many people, including me. I'm one of the products of the community chip, and if I could complete my PhD and get into the MEMS areas because of this. But how do you see in future this helping people who have the urge to learn but don't have the facility to fabricate. So how do you see this kind of program, this kind of MPW runs and community chip program helping the researchers in future?
Yeah, actually, MEMS is now an integral part of many disciplines, both science and engineering. So much so that we don't acknowledge it, saying that, oh yeah, I work in the MEMS area. Everybody uses it in one way or the other who work on things small. Of course, nanotechnology has come now, and some of the shine of MEMS is, taken by that. But MEMS is still relevant as long as the users are there to use this such a program where multi-chip activity. I think it will continue to run. I think microelectronics, it's very common even now, because one cannot afford to even put in the time to do the fabrication of an integrated chip. The similar way, MEMS also, not for all processes. If you are doing something new, you should have your own fab, which we also use it here in IISc. But for those who want to get started, or those who want to explore something where they want to focus on design, I think this is definitely useful. I think funding is something that we need to continue it, right? But then it cannot be run in a subsidized mode for a long time for it to sustain for as long as people need it. So I think we should figure out how to make it self-sustainable, where users pay, and that itself should be enough to keep it going. Another thing, actually two things, maybe three things. Design support, because when people are sending their designs to someone else to make it, there to be design rules, and also people should know what will work or what might not work, right? So they would need some guidance. In fact, in our MEMS community chip, as we called it in ISSS, we had integrated the design support. So everybody would send their designs, in fact, physically come over sometimes, and where we discuss their design, simulate them, make sure that they understand what we expect when they are made. I think the design support should continue. But after making the devices, just seeing them, somebody see an image and feeling that, oh, they are made, they need to actually test it and characterize it, right? So that is where I think we need to put in effort in the future. And finally, packaging, because that's very important. So when the device works, they have to think about that. That support is also needed. So these are the steps, I think: design support and testing and characterization support, but also for them to think about packaging and actually make it like a device. So these are the ways I think this activity should grow with adequate funding.
Well, I would just have one comment to add, which is that one of the difficulties with the MEMS multi-project chips is that the people who submit designs to them have not necessarily anticipated how the device will be packaged. And one of the primary lessons that I emphasize in my textbook on microsystem design is that the device and the package need to be co-designed so that you can anticipate how the device is going to interact with the real world. And if that isn't done, what you have is a toy. You don't have a useful device. So if I can put in a plug for co-design of packaging and chip, here it is. That's my plug.
Okay, thank you. I think we'll keep that in mind as we are taking this program further as well. So I move next to Geronimo. Geronimo and I have known now for close to 1.5 years. He visited Tyndall, and it's because of that I got to know him. And since then, we both are involved in the IEEE Sensors Council. He's a young professional himself, so the questions to him will be more on what the youngsters can look forward from industry aspects. How do you see MEMS technology in industry, and have you noticed a need for more skilled people in the MEMS area from industry perspective? How do you see it?
Thank you, Veda, for inviting me to this podcast and be here with the two big giants. So I know Professor Senturia. I don't know him personally, but I have read his book several times, and I actually use it for my classes at UC Berkeley. And then also with Professor Ananthasuresh, I also started my PhD at UPenn. So I share with him the empathy that at the beginning, the clean room I used was a very small clean room at UPenn. That was in 2010. And of course, later on, that clean room expanded to a new building, so now it's much more modern. But yeah, thank you so much. So yeah, to answer your questions, yes, I believe so. And I would say that the field of MEMS is relatively new, at least in comparison with CMOS. So it took some time to adopt in industry. At the beginning, MEMS products were bulkier and less integrated and came in open ceramic packages. For example, you may think about inkjet printers and piezoresistive pressure sensors back in the 80s. And then in the 90s, we had the first accelerometers. Now the technology is much more intricate. So for example, today, MEMS, they need to be integrated with complex CMOS circuits. They need to provide more functionality to the system. The integration happens inside the plastic SNT packages, right? So their size, power consumption, and cost, they are key factors for development. And industry is making a big effort to achieve these goals. So when it comes to hiring, they are looking for MEMS engineers that they have many hands-on skills. For example, in design and simulation, clean room fabrication, device characterization, etc. But they also need to share a diversified field of knowledge in other areas like material science, programming, or analog design. So yeah, the answer is yes. Now and more than ever, industry is in need of hiring very diverse and skillful MEMS engineers.
Thank you, Geronimo. That's great to know, because there are many young people who have joined the MEMS training, and they want to look at the industry perspective and the career perspective from industry side, what they can do if they have this skill set. Do you also see that there is a gap between demand and supply? Do you think there are sufficient number of MEMS skilled people that industry wants to hire, or is there a substantial gap in the requirement between demand and supply?
Yeah, this is a very good question. So I'm not really sure if there is a gap between supply and demand of skilled MEMS engineers. I know many university groups with a solid research background in MEMS, and these groups are supplying well-trained PhD graduates to industry. And for example, my team, whenever we are looking for a new employee, we have a handful of professors that we normally go to when it comes to hiring. On the other hand, there may exist a gap between supply and demand at the undergrad level. And the reason for that, in my opinion, is that when we compare it with analog designers, these ones, they may not require such a broad specialization. And that is in line with what Professor Senturia was saying, that for MEMS engineers, you need to have a very broad knowledge, and to acquire that broad knowledge, and also in many cases, you need to fabricate and test your devices. It requires many years of college training. So therefore, I think there are more MEMS engineers graduating with a PhD than at the undergraduate level. Another issue, in my opinion, may be that since the MEMS field is more incipient than CMOS, many industry managers or VPs and high-level employees, they don't necessarily have the background in the MEMS area. So when they come to, although they are looking for MEMS experts, maybe they don't have the background to select the proper employee. Of course, this is improving over time because now more MEMS engineers are taking leading roles in industry. And also there are places like conferences or workshops in the area of MEMS that are helping to put students and employers in contact. So that is making it easier for industry to find the right the right employee with the proper expertise. So I hope that answered your question.
Yeah, thank you. Thank you, Geronimo. So what you're essentially saying is that there is a need, there is some supply that's happening through personal networking, but there is also a requirement to upscale and advertise these positions which are not really reaching the mass. So conferences are a good platform for people to know, but there can be more things done to see that relevant openings are reaching to the real talented people. If I may conclude or summarize what you're saying.
Yeah, a good example to actually connect with the Sensor Council, a good example is IEEE Sensors Conference. We were there 1 month ago, and it was a great platform for people from academia and then people from industry to come together and then get connected and do a lot of network and bring more knowledge and recruitment in place.
Thank you very much, Jeronimo. Thank you very much, Professor Ananthasuresh. Is there a closing remark that you would like to give, Professor Ananthasuresh?
I think, yeah, it was great to listen to Professor Senturia and Geronimo here. I think it's really nice that you have taken up this activity, and there is so much interest from different parts of the world. I hope that it grows, and like I said, as long as the users are there, something like this should run.
Yeah, thank you. Thank you so much. Geronimo, do you have anything to summarize?
No, I think we saw or we discussed about MEMS from different perspectives. So I think this podcast can give a good idea, especially to newcomers to the MEMS field, from academia and then industry. And I would say from my perspective, I think the future is bright. And as Professor Senturia also mentioned, if you are interested in MEMS, you should be ready to learn many different fields. So for someone that is curious and passionate, I think it can really be like the right field of knowledge that may be looking for.
Yeah, I would like to state that I think MEMS technology can lead you anywhere. The applications are plenty. Imagination is the limit where might be, that you can think of an application. So it's all about people to try different applications and see where MEMS devices and MEMS sensors can be embedded. And what we are doing through Sensors Council and IEEE is to not only give you a hands-on training, but to give the larger society a webinar series where we are trying to cover different aspects of MEMS technology. We started from introduction to MEMS. We went to the foundry, which are going to fabricate these devices in the next year. We talked in detail about the design rules. We will be talking very soon with Jeronimo as one of the speakers on industry applications of MEMS this very week. And then we will be also talking about testing and packaging of MEMS devices, which actually summarizes everything that we were talking now, the different aspects of MEMS. And hopefully in the next year, when we have the design submissions coming up, all of the people who participated in training come forward and participate in the design submission. And each design is going to be truly global and to foster collaboration. And hopefully all devices end up working well. And we have also an option of packaging and testing them at different locations. So it's all exciting times. And thank you, Professor Ananthasuresh. Thank you, Jeronimo, for joining this podcast. And we will, of course, be having you in the training program in different aspects. Thank you very much.
Thank you, Veda.
Okay.